What's up, gangsters? We're back with another LeetCode video. It is unknown what day it is. I think this count is just severely off now. It is day 141, I believe, but we have some comments. We have from Ahmad El Hindawi. How's your Chrome layout so different? It looks really cool. Is that an extension or what? I actually did look at this comment right before I started recording. This is actually an entirely different browser. So this is not really a Chrome layout, but it is pretty much Chrome. It's actually from the Arc, the browser company of New York. They create a browser called Arc, which is pretty cool. I've been trying it out pretty recently, and I gotta say it's pretty cool. I think tabs just work better on the side of a screen, and I think they got that figured out. I'm gonna keep it a buck thowie. I think they have it figured out. Browser on the sidebar makes more sense. I mean, tabs on the sidebar makes more sense. So it's pretty cool. So yeah, maybe you can check them out. You can go, this is not sponsored by them, but you can check it out. But it could be pretty cool. It is the Arc browser. From Raj Krishan Mahajan, from Lay 140, oversimplification is also bad. I think we were doing a problem called find pivot. You can also use binary search. Actually, this is one of those problems where I don't think binary search is possible. I ended up wasting some time in the beginning of this problem because I did think that you could use binary search. It turns out I don't think it is possible, mostly because in the context of the problem, I think one of the requirements for binary search is that the data set is pre-sorted. In this problem, the data cannot be pre-sorted because the solution is based off the identity of the solution is based on the numbers in the array being in the positions they're in. But yeah, I did use the binary search pivot method in the beginning because I misread the problem, but it do be like that sometimes. It do indeed be like that. From Sam Webster, I've been watching your vids as I get suggested them, and I totally thought you were some big YouTuber with many thousand subs. Never looked till just now. Feels strong, man. I think you're onto something with your daily posting, and you certainly deserve more subs. Your explaining as you go has helped me learn to think problems when I practice on my phone as well as thinking. Feels strong, man. Feels strong. You're onto something, Sam, as a human. Feels strong, dude. Yeah, this just feels strong. I'd be cool. This channel is I'm pretty much copying Ivan Jurek, so he squats every day. Legendary squatter by day, philosopher by night. So that is the ideal goal right there. So that's pretty cool. Yeah, hopefully he can make some cool stuff too. That'd be pretty cool. Also, what is pretty cool is joining the Hyperbolic Coding Chamber Discord. So lots of cool people in there. Lots of chats going on right now. We had Elon join last week. He's been giving some talks in the Hyperbolic Coding Chamber. We've been talking. We're thinking about fusing Twitter with the Hyperbolic Coding Chamber. So big talks. You're going to want to stay tuned for that. And you can actually join the Discord and actually listen to us talk about those things. So you're going to want to join specifically for those things. But yeah, other things, the grind is progressing. I'm realizing this is one of those weeks, I think, where I'm just going to do lower time. And it just be like that sometimes. Over the channel's history, I've been looking on the history. We had we average about an hour a day, if not more. And then there's sometimes we go back down to about 30 minutes, depending on life circumstances, work, load, and other things. So it just be like that sometimes. So I think this is just one of those weeks where the time spent fluctuates. But sometimes you got to walk to run. And yeah, we'll get there. So just a daily practice. Hopefully consistency will get us where we're looking to go. That being said, where we're looking to go is LeetCode.com because we have more problems to do today. So this is the goal. We're going to be doing 30 minutes today, and I'm just going to jump into it. Hopefully me thinking through it and the explanations are helpful. Sometimes I go silent, but it's because I'm in the internal hyperbolic thinking chamber trying to figure it out. So hopefully it can make sense. So I'm going to actually go back to hiding the sidebar. And let's see if we can solve some more problemas. So we have a problem, 1275, find winner on a tic-tac-toe game. Tic-tac-toe is played by two players, A and B, on a 3x3 grid. The rules of tic-tac-toe are players take turns placing characters into empty squares. Okay, the first player A always places X characters, while the second player B always places 0 characters. Okay, X and 0 characters are always placed into empty squares, never on filled ones. The game ends when there are 3 of the same non-empty characters filling any row, column, or diagonal. The game also ends if all squares are non-empty. No more moves can be played if the game is over. Given a 2D integer array moves, where move sub I equals row sub I, call sub I, indicates that the ith move will be played on grid row sub I, call sub I. Return the winner of the game if it exists, A or B. In case the game ends in a draw, return draw. If there are still movements to play, return pending. So we're pretty much returning a string, except what we're given is a sequence of the moves played. So based on the length of the array, we can actually tell, I think automatically, whether or not the game is pending or not. So for example, let's check. You can assume that moves is valid. It follows the rules of tic-tac-toe. So that means row sub I, call sub I is within the range of 3x3. The grid is initially empty and A will play first, because A always plays X. Oh, so it's either pending, draw, or A or B wins. So 0, 0 is being played here, 2, 0 is being played here, and 1, 1. So row 1. Oh no, 2, 0, right? So 0, 1, 2, 0 is playing B turn. A makes X, B makes O here, and then A makes this final X, pretty much making certain that they win the game. So I think I actually did realize I didn't even start the timer, but I think we'll just write like this time. So I think we can basically just say, we could just build the board and then just check using a recursive function if there's a winner. Well, I don't think we also even have to do that. I think we can just pretty much implement a function called check diagonal and check horizontal and vertical. And for pretty much anywhere we have X, we'll just call that function. And anywhere we have 0, we'll call that function. And then whenever it returns true, we can return that either A1 or B1. And in terms of checking if the winner is pending or if there's a draw, there's 9 squares, which means that for it to end in the draw, there must be at least 9 elements in the array. If there's 9 elements in the array, we actually can't know if there's a draw until after. So we can actually return draw at the end, because if all 9 positions are filled, it could be that the player just won by placing in that last spot. So we'd end up having to check the matrix to make sure that's true. So we can return draw at the end. And then what we can do actually is just say if moves dot length, well, you actually can win in less than 9 moves. So I would say after we check who won, if we found that no one won, right, what we can do, right, is if moves.length equals if moves.length is less than 9, then here's where we would return pending. because if we weren't able to find a winner, right, in the game, and the board isn't filled, if the board isn't filled, it means the game isn't over yet. If the board is filled, right, then we would return draw because it means that there was a draw. So now we just need to check who won. Now I wonder if you could do this without forming the actual. I wonder if you could do this without actually building the matrix with the solutions. Now that I'm thinking about it, this already is the matrix of the solution, or of the completed matrix. I guess we can just check based on odd and evens. Even would be A, so we can just check. Maybe let's just make it right first. We could just view this as the completed move set, right? And odd would be A. And so how would we check diagonal? Well, we would check that the first index, right, is equal to 0, 0, and then we could check if 1, 1, right? And then we could check if 2, 2, that would pretty much mean that they have a diagonal win going down into the right. The other thing we'd need to be able to check is if they have a diagonal win going down into the left. And then left to right to left is the same. So is up and down and up. So I think as long as we check write a function called did win, it'll take in moves, which could be an array of numbers, which pretty much are just passing in moves, right? And it's going to have to make sure to return a Boolean. The other thing it's going to take is the player, right, which is going to be a string. Or it can actually just be a number. Will be player, but it's actually just going to be a number. And then you have to make sure to check both diagonals. Actually, and what's the size of the board? It's going to be max at 9. Moves out length is always equal to 2. Right, and it's going to be less than or equal to 0. So we'll check both diagonals and then top and bottom. This would pretty much be n squared, because for each point, for each element, we end up checking n squared. And one thing we can do is start at since one player always goes first and the other person goes second, the other thing we can do is start at the third at minimum it takes at least 6. This is just pre-optimization, so this actually doesn't matter, but we can just iterate through, and based on the player's number is how much we'll skip through when calculating this. So we want to check both diagonals. So we could just do a loop for each one. We could check going from left to bottom right, then or just going from left to right and then right to left and then up and down and down and up. But if we pass in a value like x here, we can go from the top left, so from x to the bottom right. I kind of just want to write it and figure it out, but I'm trying to get in a good practice visualizing the algorithm before I write it. Do we just write 3 separate for loops? If you write 3 separate for loops, it always assumes that we're working from the top row. I'd like the algorithm to work no matter how large the board is. Yeah, I think we can actually do a simpler version if we just actually remove this entire did win function, and instead we could just make pretty much 3 functions to check, or 4 functions to check winning ability. So we could make a function that checks diagonal LR, would take in moves number, right? And it would take a row and a column. And it's pretty much going to check going from top left to bottom right. And if you go out of bounds, it also just counts as true. Mm-hmm. this whole thing is simpler. I'm realizing if we just had board, which would be an array of strings, and we just represent the board instead of the board as moves. This lets us just check if the symbols are all the same. So in this diagonal function, we could pass in board, and the goal, you'd pass in it as well as a row, column, and a symbol, and it would pretty much just check going from top left to bottom right if things basically make sense. So if the symbol matches the other symbol, right, then we'll keep going, even further bottom right until we go out of bounds, until we pretty much return true. If we concatenate all the Boolean expressions and it's true, then we'll return true. The only problem is that this is technically a lot of code, but I don't think it really matters. And before we can write these functions, we're going to pretty much need to create the board. So we'd have to create board, which would be an array of strings. And we would pretty much iterate through the whole array of moves. Row is less than moves. Dot length, row plus plus. Then we could duplicate this, except do it for columns. Columns are going to be dependent on the row. And then from here, this is actually the wrong method. I think we want to do something more like this. Const row call of moves. That way we can get each as a pair of moves. And we'll say player is equal to 0 for A to start. Right? And I think they always said that first player, A, always places X characters. So we'll change this, to A. We'll say now we need to fill the board with the rows and the columns. We pretty much need 3 arrays, so that I is equal to 3, I is less than 3, I plus plus. Duplicate this and just do and we pretty much just need a 3-dimensional version of board. We're just going to do board dot push an empty string. And then here we'll do board dot push an empty array. And then here we can just say board sub row sub column equals player, and then player equals, if player is already A, then we'll change it to B, otherwise we'll change it to A. First one is this, right? I think we output pending, which is fine. Just want to see if the board actually makes sense. And it actually does. So we have the board. Now that we have the board, we can pretty much just iterate over the whole thing again. What we'll say is if diagonal LR, and we'll pass in the board, right? And the symbol here is just going to be board sub I sub M. And now that I'm realizing it, we can actually leave out. You can actually leave out the symbol and just pass in I and M. We're gonna add a couple more. If they all return true, then we'll return board sub I sub M as the winner. Then here we'll remove symbol. And then here we just want to check from diagonal left to right. So to do that, we'd need a base case. And it's pretty much going to be that 1 to go up a column. So we row -1, right? Let's say we're in column 1. To go up, we'd -1 and subtract 1 to column. So that's going left to right, right? So we'll say if top left is right, so we'll say if board sub row -1 sub column -1 equals, or first, if it exists, right? And if boards sub row -1 sub column -1 equals, or yeah, does not equal board sub row, right? Board sub column, right? So here we're at X. We're pretty much saying, okay, do these match? And if they don't match, right, we'd want to return false. We also want to do the same for going forward. And then we have this case here. Can I make this like wider? So I have this case here. We'll say or. Pretty much the other case, which is going forward 1, so we'd go forward 1. Want to make sure that 1, it exists, and 2, it matches the current one. Then we'll return false. They didn't win. Otherwise, we want to return true, right? And diagonal LR, right, passing in board with row -1, column -1, so we'd like to keep going, right, and diagonal LR, row +1, column +1. The other thing, right, is if they're out of bounds, we also want to do one more thing. So say if board sub row will return true. So if you go out of bounds, it is true. So for example, if we start at X here, right? We check if before us was not the same symbol. It is the same symbol. We check if after it is not the same symbol. It is the same symbol. So then we'd return true and do the same thing for before. So now it'd be here. We check before us, and by checking before us, this wouldn't go through because one board sub row -1 and +1 and column -1 and column +1 don't exist. And we'd say, okay, well, do they exist at all? It doesn't, so we'd return true for that. Actually, well, yeah, so it does exist, and then we do diagonal for before. Now it'd be true, and we actually do end up duplicating some work here. Why is this problem so sticky? I don't understand. This actually doesn't work because now we won't be able to know when we've already seen something. I think we might have overcomplicated it. In reality, you can only win diagonally from a few different locations, and they're all odd. It's either this index going down right, this index going down right, or this index, which is pretty much, it's just those two indexes basically, because they check the same forwards and backwards. So we can just check if anyone won diagonally, we can return the winner, and did anyone win going across? Did anyone win going up? So I think we can throw out all this nonsense. We can keep the board. Yeah, I think we overcomplicated this really badly. To check the diagonal, you can just say if board sub 0 and board sub 1 and board sub 2 and board sub 0 equals board sub 1 and board sub 1 equals board sub 2. And if that's true, you can just return whoever was at board sub 0 because it's the same. And then you can just duplicate that same case except going in the opposite direction. Okay, so you go 0, 1, 2. Oh no, it'd still be 0 except you'd be at index 2. 1, 1 would stay the same. Instead of 2, 2, you'd actually just be 2, 0. This would be 0, 2. And this would just be this would just be 2, 1, 1, and we'd have 2, 0. And so yeah, this final one would also just be 2, 0. And if it's all true, we just return whichever one was there. And then for checking the remainder, you can just check horizontally by doing a if statement. And we'll just say row equals 0, row is less than board.length, row plus plus. And we'll just say if board sub row sub 0, board sub row sub 1, board sub row sub 2, right? And pretty much everything we did up here, we're pretty much just going to copy it. We'll just say board sub row sub 0 equals board sub row sub 1, and board sub row sub 1 equals board sub row sub 2. Then we could just return board sub row sub 1. And this would be the same for being checking vertically, except we just change row to column. And it's kind of like the transpose matrix problem. So before we were going like this, so first row, second row, third row. Now we're just going to be going through the columns. So we go 0, 1, 2. Right. So yeah, it would stay the same, except it would always be board sub 0, which is the same. So wherever row was, we'll just place 0. And then where 0, in the second one, we can just place the column. So it's always going to be the first row, except the column. Since we're checking, I forgot we're not checking her. Wait. Yeah, we're checking vertically. Since we're checking vertically, it's the column that changes. So board sub 0 and 1 and 2 have to exist, and then the column will be swapped out. Right, and we'd say board sub 0 sub call equals board sub 1 sub call, and board sub 1 sub column would be equal to board sub 2 sub column. In that case, we return. Yeah, something was just confusing about that problem. I think it's because I don't understand. Something was just very confusing about that problem. We do linear time to build the board. That's going to be linear time based on the number of elements and moves which is at max 9. We build an auxiliary space. We could just, so say linear space and linear time. I wonder what the best you can do on this problem is. Okay, maybe this problem wasn't simple. Yeah, it looks like you can't avoid some sticky thinking here. This is literally what we are going to do earlier. But I got lost in the sauce with the recursion, and I realized recursion is definitely not the play. So I'm going to stop there, and we still ended up doing like 42 minutes, so